how elevators work.
Have you ever wondered why you feel heavy when going up in an elevator and light when going down? If you stand on a scale in an elevator accelerating upward, the scale must exert an upward force greater than the downward force of your weight, vice versa for when the elevator accelerates downward.
To solve for elevator problems, you need to start by making a diagram. In our diagram, we have a person in an elevator and two arrows. The first arrow represents the force of gravity acting upon the person, and the second arrow represents Fn, which is what we're trying to solve for using the formula Fn equals mg. The formulas we're going to be using for elevator problems are Fnet equals ma, Fnet equals mg, and F scale equals ma plus mg.
The units you want to use for elevator problems are kilograms, meters per second squared, and newtons. We will now be doing some sample problems. Assume that a scale in an elevator is on Earth. What force would the scale exert on a 53 kilogram person when the elevator slows at 3 meters per second while moving up? We first draw a diagram and then give our known values. We then can solve the problem using the equation F scale equals mg plus ma. We then plug in our known values and the answer ends up being 360.4 newtons. Sally wants to see what happens when she stands on a scale while riding in an elevator. Find the force. Her mass is 64 kilograms and the elevator is moving down at a constant speed. We first draw our diagram, list our known values, and then we use the formula F scale equals mg. We plug in our known values and that equals 627.2 newtons. Jack stands on a scale in an elevator at rest on the 64th floor of a building. The scale reads 436 newtons. His mass is 62 kilograms. It begins to accelerate upward. Find its acceleration. So as usual, we draw our diagram and list our known values. We then use Fnet equals ma, and we plug in and solve for that. And the answer is 7.03 meters per second squared. Katie stood on a scale in an elevator. The force exerted was 312 newtons. The elevator remained at a constant speed until it reached the top level of the building. Find Katie's mass. So we draw our diagram, give our known values, and we use the formula Fnet equals mg, and we plug in, and we divide by 9.8 on both sides to get the mass, which is 31.84 kilograms.
Your mass is 75 kilograms, and you are standing on a bathroom scale in an elevator, starting from rest. It accelerates upward for 2 seconds and then continues at a constant speed. Okay, to start the problem off, we're going to make a diagram and write down our known values, and we're going to be looking for F. Okay, to start off the problem, we're going to be using the formula Fn equals ma. Then plug in ma with 75 kilograms and 2 meters per second squared. And our result for that will be Fn equals 150 newtons. Then we're going to use the formula Fg equals mg and plug in for mg 75 kilograms and 9.8 meters per second squared to get Fg equals 735 newtons. For the final part of our problem, we're going to be using the formula F scale equals Fn plus Fg, or ma plus mg. And to do that, we're going to plug in for the formula with 150 newtons and 735 newtons. And that will come out to a result of 885 newtons. The mass of a person in an elevator that's not moving is 72.2 kilograms, and find Fnet. So we're going to solve this by first writing down our formula, which is Fn equals mg. Then we're going to plug in our known values into the formula. So our known is the mass, which is 72.2 kilograms, and also the gravity, or gravity in general, which is 9.8 meters per second. To complete solving the problem, we're going to multiply 72.2 kilograms and 9.8 meters per second to get Fn equals 707.56 newtons.